Hello and welcome dear students. I am SHRAVAN, your maths lecturer. We have started with the chapter differentiation. In the last lecture we have seen some basic formulae of differentiation. Now today we will start with the next topic, that is rules of differentiation. The first rule of differentiation is what? Suppose we have to differentiate k into u, where k is any constant and u is any variable. Variable means what? Here we are differentiating y with respect to x. If we are differentiating any term with respect to x, then x is considered as variable and we are denoting the function by y. Therefore, x and y are variable and remaining terms are known as what? Constant. So here we are taking, suppose y is equal to k into u, where u is any variable. Variable means what? It contains the terms of x, suppose e raised to x, log x, sin x, x square. So here k is constant and u is any variable, and suppose we want to differentiate y is equal to k into u. So how to differentiate y is equal to k into u? Differentiate with respect to x. So differentiate means what? Write down d by dx on both the sides and take constant common. Here k is constant, so constant into variable, differentiation of variable. For example, suppose we have y is equal to 5x cube. 5x cube, here 5 into x cube, here 5 is constant and this term involves terms x, and here we are differentiating with respect to x, therefore x cube is variable. So how to differentiate this? Differentiating with respect to x, write down d by dx on both the sides. Here 5 is constant, so taking 5 constant common and derivative of x cube. Now we know that x raised to n formula. What is x raised to n derivative? N into x raised to n minus 1. Here n is what? 3 and 3 minus 1 is 2. So the answer is what? 15x square. So the first rule is what? When constant into any variable is there, then constant you have to take common and differentiate the variable term. Suppose we have only single constant, y is equal to 5. If we have only single constant, then derivative of single constant is 0. Derivative of single constant is what? 0. But if constant into variable, suppose we have constant into variable, 5 into e raised to x, so 5 you have to take common and differentiate the variable term. So derivative of e raised to x is what? E raised to x. So this is the first rule. If we have one constant into variable, then constant you have to take common and differentiate the variable term. Now second rule is sum or difference rule. Suppose we have the term, second rule, sum or difference rule, k constant or a into b plus or minus b into b or plus or minus any 2 or 3 terms. Here we are taking 2 terms as examples. Now differentiating with respect to x. If we have plus minus term, then write down d by dx with all the terms. Here a and b we are taking as constant and u and v are the variable. So taking constant common and differentiating u plus or minus b derivative of v. For example, y is equal to 3x square minus 5x plus 2. Here we have sum or difference terms. So what is the rule of sum or difference term? Write down d by dx operator with all the terms and take constant common. So dy by dx is equal to 3 is constant, so taking common and derivative of x square minus 5 constant derivative of x plus this is single constant, so no need to take common. Now what is the derivative of x square? All of you know that derivative of x square is 2x using x raised to n formula minus that of x is derivative of x is 1 and derivative of single constant is 0. So the answer is 6x minus 5. So this is the final answer of dy by dx, 6x minus 5. So what is the second rule? If we have 2 or more terms which are added with plus or minus, then write down dy by dx with all the terms and take constant common if constant into variable is there. Now third rule is product rule. This is the important rule. Third and fourth rule are very important. Product rule. What is the product rule? Suppose we have 2 terms which are in product or which are in multiplication, two terms means for two variable, not one constant, one variable. Suppose we have y is equal to u into v, and we want to differentiate u into v. Where u and v are the terms of x, means u and v are the variable. So how to differentiate u into v? U into derivative of v plus v into derivative of u. Don't directly do u into v like derivative of u into derivative of v. This is possible only for plus or minus, not for multiplication and division. For if you have two or more variables in multiply or division, then you have to follow product rule and division rule. Now u into v is what? U into derivative of v plus v into derivative of u. For example, suppose we have y is equal to x into e raised to x. Here x is variable, e raised to x is also variable, and in between x and e raised to x multiplication sign is there. If we have plus minus sign, then directly we can differentiate. For example, x plus e raised to x or x minus e raised to x, then directly this we can differentiate as derivative of x plus derivative of e raised to x. Derivative of x is 1 and derivative of e raised to x is what? E raised to x. So this is the answer of x plus e raised to x. But here x into e raised to x is there. Instead of plus or minus, we have multiplication sign. So whenever you have two variables in multiply, then you have to follow product rule. Now what is the product rule? Product rule is what? Keep first, means u derivative of v plus v derivative of u. U derivative of v plus v derivative of u means keep first, differentiate second, plus keep second, differentiate first. Now apply the formula e raised to x. Here d by dx operator is only with e raised to x, so x will remain as it is. X into e raised to x derivative is what? E raised to x plus e raised to x as it is, and derivative of x is what? 1. Now here you can take e raised to x common, so the answer is x plus 1. So this is the answer of derivative of x into e raised to x. This is product rule. Whenever you have two variables in multiply, then always you have to follow product rule. Two variables, I am talking about two variable. If you have one constant, one variable, 3 into x, then no need to apply derivative into v. You can take directly 3 common and derivative of y, taking 3 common, derivative of x. So the answer is what? 3 into 1, that is 3. So whenever you have two variables, that is terms involving x in multiply or divide, then you have to follow product rule and quotient rule. The last rule is what? Quotient rule or division rule. Fourth rule is u upon v rule. Division rule. Suppose you have two variables in division, then directly you cannot apply du by dx and dv by dx. So how to do the differentiation? Differentiating with respect to x. So the answer is what? You have to start from v into derivative of u minus u into derivative of v upon v square. Always start from v into derivative of u minus u into derivative of v upon v square. So you directly cannot differentiate as, suppose we have x square upon log x. So you directly can't do it as derivative of x square upon derivative of log x, and this is wrong. So while using, when you have two variables in product or division, then you have to apply multiplication rule and division rule. For example, suppose we have e raised to x upon x. Here e raised to x and x are two terms which are in division, so you cannot apply d by dx with both terms directly, derivative of e raised to x and derivative of x. Here you have to follow u upon v rule. Now what is u upon v rule? Always you have to start from v into derivative of u is what? E raised to x minus u derivative of v is what? X upon x square. So x e raised to x, derivative of e raised to x is e raised to x, and derivative of x is what? 1 upon x square. Now here you can take e raised to x common, so the answer is x minus e raised to x into x minus 1 upon x square. If you do directly e raised to x upon x, so derivative of y is equal to derivative of e raised to x upon derivative of x. This is completely wrong. whenever you have two variables means what here we are differentiating with respect to x. So the terms involving x are the variable and remaining terms are what? Constant. But if we have one constant, one variable in division, for example 2 upon x, then you no need to apply the quotient rule here, you can take 2 common. So differentiating 2 common and derivative of 1 upon x. Taking 2 common, we are left with what? 1 upon x only. And derivative of 1 upon x, we know that minus 1 upon x square. So the answer is minus 2 upon x square. So these are the 4 rules that you have to prepare for differentiation to solve all the sums of differentiation of first exercise. In the next lecture, we will see the derivative of composite function. Thank you.